In this lesson, we're going to talk about miscellaneous measurements. In the previous lesson, we began to talk about volume, and we talked about the volume of a rectangular solid. Now we want to add a little bit to that list and talk about the volumes of a few other standard figures. Notice first off is our rectangular solid, just like we had before. Another new formula is the rectangular pyramid, which is this one right here. It looks just like a rectangular solid at the base, but as it goes up, instead of coming up vertically, it comes up to a point. And you'll notice that it uses exactly the same formula as the rectangular solid, except for it has a 1/3 in front. This is true when you have a relationship between solids with the same base, where one is just straight vertical and one comes to a point. With that said, the next one is the right circular cylinder, and it has the formula pi r squared h. Pi r squared is the area of the circle times the height of the cylinder, and that actually gives you volume. And then similarly, the right circular cone has the same base but comes up to a point, so you have a 1/3 pi r squared h, whereas for the cylinder it was just pi r squared h. For the sphere it has a formula all of its own, 4/3 pi r cubed. It's a kind of weird formula to try to set up, so let's just not talk about that. Let's do a few examples. Find the volume of a rectangular solid with length 5 centimeters, width 4 centimeters, and height 11 centimeters. For this one, the volume is just simply length times width times height. So let's plug it in. 5 times 4 times 11 is equal to 220, and our units here are centimeters cubed, because again we're looking at volume. Next example. Find the volume of a rectangular pyramid with length 18 centimeters, width 10 centimeters, and height, we'll have to draw it to a point, 3 centimeters. That's a very short pyramid. Hopefully this drawing gives you a little bit of a visual of this pyramid. It's very short. And the formula for the volume of a pyramid is 1/3 length times width times height. So let's plug in what we have. We have a 1/3, the length is 18, the width is 10, and the height is 3. I see a little numerical shortcut, so it definitely won't hurt to show it to you. The 1/3 and the 3 cancel out. So I have 180, and again we have centimeters cubed. Next one. Find the volume of a right circular cone that has a radius of 2, that's actually decimeters there, and a height of 3 decimeters. When we draw a cone, it has a circular base, but from perspective it looks more elliptical. And I draw the dashed in the back. And then we come up, and now let's fill in our measurements. The radius is 2 decimeters, and the height is 3 decimeters. Now the volume of a right circular cone is 1/3 pi r squared h. So we get 1/3. Pi is 3.14, but remember your pi key may be needed for homework problems. R is 2, and h is 3. Again, I see the same simplification. The 1/3 and the 3 can cancel out, and we're left with 3.14 times 2 squared, which is 12.56. And this time we're looking at decimeters cubed. Next example. Find the volume of a cylinder with diameter 6 inches and height 13 inches. Usually for a cylinder, I'll start with an ellipse, and it's got a diameter of 6 inches. Remember that even though this looks like an ellipse, it's a circle. Then it comes down with a height of 13 inches. And then let's just draw the other base. The volume is pi r squared h. But there's a small problem. The diameter is 6 inches. I need a radius, so if you're not given the radius, make sure to cut the diameter in half and see that the radius is 3 inches. I get 3.14 times 3 squared times 13. And when I do that, I get 367.38, and this would be inches cubed. If you use the pi key here, your answer would probably be a little bit larger. Last one, find the volume of a sphere with diameter 9 millimeters. For a sphere, I usually start by drawing a circle, and then draw sort of a outside line horizontally and vertically. And then we are given that the diameter is 9 millimeters. This is a pretty small sphere, probably about the size of a BB. Now the volume formula for a sphere is 4/3 pi r cubed. So then I have 4/3. Pi I'll use 3.14, but we're running into the same problem again. I'm given a diameter of 9 millimeters. So the radius is half of that, which is 4.5 millimeters. So then I'll put in 4.5 cubed into the formula. I get 381.51 millimeters cubed. A cubic millimeter is extremely small. It's about the size of a grain of sand. So you can imagine that there's enough to fill in there. Now let's talk about mass and weight. Mass measures how much matter is in an object. So mass is very relative to gravity if you're trying to measure it itself. However, one way to measure mass is to use a balance scale. So imagine that you've got two sides and you've got something you're trying to find the mass of. And on the other side you have some known masses. So perhaps you have a little 1 kilogram weight. This will give you a mass measurement no matter what. However, the difference is with weight. Weight is a force. Weight is what you feel when you pick up a mass. So gravity has an effect on weight. That's why if you go to the moon, you weigh less, but your mass would not change. If you were to stand on a giant balance scale, you would be balanced out by the same number of objects that give you your weight on Earth. So how do we compare these two? Well, mass is generally a metric system thing, but they actually do it a little bit weird. Whenever someone is asked how much they weigh, or we're talking about the weights of objects, for some reason in the metric system they actually give a weight in grams, kilograms, or milligrams. However, that's not actually a weight. So what we do is we will assume that if 1 kilogram is called a weight, then that weight represents 1 kilogram of mass at sea level. With that said, if you think of a kilogram in that fashion, you can convert it to the standard US system that uses pounds, ounces, and tons. Note that there are 16 ounces in a pound, and there are 2,000 pounds in 1 US ton. We'll talk about a metric ton as well, and that some of the system used in the metric system, they have a kilogram, which if you understand the sliding scale already, the kilogram is just 1,000, for that's what kilo stands for, 1,000 grams. And then 1 gram would be 1,000 milligrams. Milligram is a very small weight. Think of a milligram as the weight of a particle of sand. The metric system also has what we call a metric ton, which is 1,000 kilograms. Just to get a feel for a gram, 1 gram is about the weight of a paperclip. And then for other conversions, you can try to figure it out based on these. 1 kilogram is equal to 2.2 pounds. And so flipping that around, 1 pound would be 0.45 of a kilogram. This conversion right here is extremely commonly used in the medical field. So now one more thing to point out here is that if a kilogram is 2.2 pounds, then a metric ton, being 1,000 kilograms, would be 2,200 pounds. With that said, 1 metric ton could be looked at as 1.1 US tons. Another unit that we sometimes need to change between are Fahrenheit and Celsius, units for temperature. Some common temperatures in both of these systems is that water freezes at 32 degrees Fahrenheit, but in the Celsius scale, that's 0 degrees Celsius. Water boils at 212 degrees Fahrenheit on the Fahrenheit scale, and water boils at 100 degrees Celsius on that scale. You can kind of see where the Celsius scale came about. 0 was based on water freezing, 100 was based on water boiling. Fahrenheit has a bit of a weird situation. Also, the human body, even though this has been a little bit disputed recently, is that there's 37 degrees Celsius for the original temperature of the human body, and in Fahrenheit that's 98.6. Commonly we're interested in temperatures involving atmospheric, based on how hot it is outside, how cool your house is inside. Your body temperature is important to detect if you have a fever and if you're sick, and also the cooking temperatures are a very important thing for these scales. To convert between the two, we use two different equations. Basically, if you're given Fahrenheit, you can plug it in right here and find Celsius. If you're given Celsius, you can plug it in and get Fahrenheit. Let's do a couple of these conversions. Convert 86 degrees Fahrenheit to Celsius. Again, I'm given Fahrenheit, so I'll plug it into the first equation. Celsius would be 5/9 of 86 minus 32. And then just follow your order of operations. Parentheses first, we get 54. And then it's kind of easy to calculate this if you're careful. 54 divided by 9 is 6. 6 times 5 is 30 degrees Celsius. Another way you could do this is just do 5 divided by 9 times 54 in your calculator, and it should spit out 30 as well. How hot or cold is 40 degrees Celsius? 40 degrees, if we just think about it as Fahrenheit like we're used to, 40 degrees is a little bit cold. Not too cold, but a little bit. But in Celsius, you can already look at the previous problem and say, yeah, that's going to be pretty hot. 30 degrees was 86 Fahrenheit. 40 degrees, well, let's find out. We'll use this equation because it allows you to plug in Celsius. Fahrenheit is equal to 9/5 of 40 plus 32. I'll use the same little trick. 40 divided by 5 is 8. 8 times 9 is 72. Still got my plus 32, and I get 104 degrees Fahrenheit. Hot! You would not want to go outside on a day where it's that hot outside. Now let's talk in more detail about the metric prefixes. We talked about how they were related to each other and gave some definitions. But now I want to show you the scale. A millimeter, we said before, was 1/1000th of a meter. One way to look at it is 1 meter is made up of 1,000 millimeters. A centimeter is 1/100th of a meter, so 1 meter could be made up of 100 centimeters. Similarly, 1 meter could be made up of 10 decimeters, and then deca means 10, hecto means 100, and kilo means 1,000. So we have all these powers of 10 going on. Here's how we actually make our conversions. You may recall this phrase that you've probably come across before. King Henry died Sunday drinking chocolate milk. Now, the problem that I have with this is there's two D's. I prefer to put a little a down here to represent the deca comes on the left side. But either way, King Henry died Sunday drinking chocolate milk. These are all the prefixes, and S stands for whatever the standard unit you're using at the time is. It could be meters, grams, liters, etc. And there are others. If we want to go from a large unit like a kilometer to a smaller unit like a meter, we would multiply by a power of 10 with the 3 decimal places that we're moving. All we really have to do then is just say we're starting at kilo, we're moving 3 steps to S, and that means I would move 3 to the right. Whatever you do to the scale up here, you do to the number. To change from a small unit to a large unit, let's say millimeters to centimeters. I could move 1 place to the left to get from millimeters to centimeters, and so I would divide by that power of 10, which equates to moving my decimal point, 1 to the left. One nice thing about checking your answers is if you go from a large unit to a small unit, you'll always multiply and get a larger number. This is true in general. If you go from a small unit to a large unit, you'll divide and end up getting a smaller number. We've been doing some of that already in this course. Let's do a few of these conversions to get some practice. I'm going to go ahead and write the sliding scale up here. Remember, I usually put the little subscript A. King Henry died Sunday drinking chocolate milk. Now let's take a look at this. 35, I will put the decimal point at the end because there's no decimal point written. And now we find our place on the sliding scale. We're starting at meters. Where is meters on the sliding scale? If you said M, nice try. That's actually the milli prefix. Meter is the standard unit. So we're starting at S. In order to go from meters to centimeters, I need to move 1, 2 places to the right. So I'm going to move 1, 2 places to the right and fill in the zeros to say that 35 meters is 3,500 centimeters. Let's do another one. Centimeters to millimeters. I'll copy down my number, and then I need to go from centi, which is right here, to milli, which is right here. I'm going to move 1 place to the right. And that gives me 64 millimeters. In the next one, we have 0.234 meters, and again, that's the S that we're looking at. And then we're moving to decimeters, which is the one on the right. So we're going to move 1 space to the right in order to do this. That gives me 2.34 decimeters. Let's do some more of these. Again, your scale is King Henry died Sunday drinking chocolate milk. For 6 meters, the decimal point is at the end again. Remember, meters is your S, and so we're going 1, 2, 3 places to the right to go to millimeters. That gives me 6,000 millimeters. Meters to kilometers. Let's write down the 5.9. I'm starting with meters, and I'm moving to kilometers, which, we finally got one that's on the left. Kilometers is over here. I need to go 1, 2, 3 places to the left with my decimal point. 1, 2, 3. That puts my decimal point right here and fills in 2 zeros. So to write a clean final answer, I'll say that's 0.0059 kilometers. That's a short number of meters compared to kilometers, so it should be a very small number. 320 millimeters, the decimal point is at the end, and so milli is right here. We're going to go 1, 2, 3 to the left to get to the standard unit of meters. 1, 2, 3. There's our new decimal point. So we get 0.32, I'll put the 0 even though I kind of don't need it, meters. Let's look at our scale again. King Henry died Sunday drinking chocolate milk. Now we're going from kilograms to grams. We're not using meters again. However, it's the same idea. The G is going to be S on a sliding scale. That's your standard unit. So I'm going from kilograms, 3 to the right, to grams. The 121 is going to go 3 to the right, and I'll have 121,000 grams. Now, kilograms to metric tons. This is not on this sliding scale at all. However, I do know that there are 1,000 kilograms in a metric ton. So I will start with my 3,500 kilograms. I'm going from a smaller unit to a larger unit, so I need to divide by 1,000 kilograms per metric ton. And that will take me to 3.5 metric tons. Just write it up here for completeness. Last one is back on the sliding scale. Your 12,600 has a decimal point at the end. We're going from milligrams to grams. That's 1, 2, 3 to the left. 1, 2, 3 to the left. Gives me, I'll just say 12.6 grams this time. Let's put our sliding scale on these. King Henry died Sunday drinking chocolate milk. However, you'll notice that the second one here is the only one that's going to use it. 300 centimeters cubed to liters. A centimeter cubed is much smaller than a liter, so I'm going to need to divide like I did on the last slide. We'll take our 300 centimeters cubed and divide by however many centimeters cubed are in a liter. You might need to look back and see, but it is 1,000 centimeters cubed in a liter. 300 divided by 1,000 is 0.3 liters, which I'll just write up here. Milliliters to liters. We can use our sliding scale for this one. Milli is right here, and liters are now our standard unit. So I'm going 1, 2, 3 to the left, 1, 2, 3 to the left, and that gives me 0.353 liters. The final example is actually the easiest of them all. How many centimeters cubed are in a milliliter? 1. They're actually exactly the same. A milliliter is a centimeter cubed. That's the definition in some ways. And so there's 124 centimeters cubed where there's 124 milliliters.